Hello students, this is Professor Mahajan MR. Welcome you all for online course Emerging Trends in Mechanical Engineering. The unit for discussion is Unit 2 Process Engineering. Course outcome: at the end of this course, students will be able to apply heat engineering principles in process boilers and waste heat recovery systems used in process industry. Unit outcome for this session is list commercially viable waste heat recovery devices. Agenda for the session is waste heat recovery systems, potential, benefits, constraints, and also at the end we will see one heat recovery system, that is condensate heat recovery pump. Let us define the process of waste heat recovery. It is a process of recovering heat energy that otherwise would have wasted to atmosphere and use it back into the process plant economically and environment friendly manner. There are various methods to achieve this, which we will discuss subsequently in coming sessions. Waste heat recovery leads to great energy saving and will result in increased thermal efficiency of different plants. Basic question is, why heat goes waste? Either processes are not efficient, so we can try to make them more and more efficient by analyzing. Secondly, there can be thermodynamic limitation of the process, because of which the heat bound to go waste, and here waste heat recovery devices plays important role. The need of waste heat recovery is, there are rising energy costs and we are facing environmental degradation problems by burning of fossil fuels. It is estimated that 20 to 50% of the energy used in industry is rejected as waste heat, and therefore there is a lot of potential in recovery of this heat. Some industries like chemical industries, refineries, other industries like heating, ventilating and air conditioning, power plants, engine coolants, distillation condensates, heat pump and refrigerators are some of the areas where waste heat recovery can be done with better efficiency. There are certain benefits of waste heat recovery systems. Direct benefits include reduction in utility consumption, that is electricity, water or gas consumption. Also process cost get reduced. Indirect benefits include reduced pollution in terms of carbon dioxide, carbon black, oil sludge in crude oil industry, sour gases which contains hydrogen sulfide, etc. Also, there is a reduction in equipment sizes like fans, stocks or chimneys, burners, ducts, etc., which means there is a reduction in capital investment. There is a reduction in auxiliary energy consumption, that is, electricity consumed by fans, pumps, compressors, etc. We can generate mechanical work using waste heat, like we can rotate turbines that can drive pumps or compressors. Also, electricity can be generated for in-house use, or you can sell the electricity to neighboring plant, or you can add it to the grid. Let us see some typical waste heat recovery sources and the quality of this source with potential application. First is flue gases from boilers or diesel engines or gas turbines. Their quality or grade depends upon the temperature of these gases. This can be used in economizers, air preheaters, waste heat boilers, etc. places. Second heat source is vapor streams coming out from cooling towers or flash steam generated in the plant. Again, the quality depends on the temperature of these vapor streams and also amount of heat that is liberated during the condensation of these vapors. Third is convective and radiation heat losses from exterior of the equipments like boiler furnace walls. Normally it is a low grade source of waste heat and it can be used in space heating or air preheating. Another heat source is chilled water supply or disposal. This is high grade loss if we are using it in refrigeration, and if it is used in heat pump, it is a low grade kind of waste heat source. Heat in gaseous or liquid effluents. Effluents are waste coming out from any process, maybe liquid or gas. If it is heavily contaminated, the quality is poor and it will require alloy heat exchangers. Products leaving the process can be also good waste heat recovery source. For example, slag in steel making process, various byproducts of various process industries, and again the quality depends upon the temperature of this particular heat source. In this slide, let us see some devices with temperatures at which waste heat is available. Typically, they are classified in low, medium, and high temperature sources. In high temperature, there are various metal refining furnaces like for nickel, aluminum, zinc, copper. Also, glass melting furnaces, solid waste incinerators, and the temperature of waste heat available is 650 degrees centigrade to 1650 degrees centigrade. Second class is medium temperature devices, boilers, gas turbines, internal combustion engines, annealing furnaces. Here waste heat is available at 230 to 650 degrees centigrade. Some low temperature devices include process steam condensate available at 55 to 88 degrees centigrade, cooling water in furnace doors, bearings, welding machines, cooling of these, refrigeration condensers, pumps and compressors, they all have potential of 27 to 88 degrees centigrade. There are certain constraints in using waste heat recovery. First is quantity and temperature of waste heat. It should be large enough, otherwise waste heat recovery systems will become uneconomical. Use of recovered waste heat, if it is made for generating low pressure steam that is already available in the plant in excess amount, there will not be any returns from the waste heat recovery systems. Space availability is big constraint in many plants. To locate waste heat recovery units, you will need certain space. Allowable temperature limitations is important because many a times at low temperatures harmful acids will condense out from the waste gases and they may damage carbon steel parts of waste heat recovery system. So there are restrictions in reducing temperatures of waste gases in many cases. Minimum and maximum temperature of process fluid. WHR systems should be able to maintain the temperature of process fluid within the desired zone. Say, in a certain industry, you may need to maintain a certain temperature within tolerance of plus or minus 5 degrees centigrade. So that has to be maintained. Sometimes it may not happen. Chemical composition of waste heat process fluids. It affects on selection of material, and in certain cases that may increase the cost of WHR systems if you need to select costlier materials for the same. Facility heat to power ratio should be optimum. If the heat to power ratio in the facility is higher than the cogeneration plant, The excess demand of the steam will be met by utility boilers. Any saving in the steam demand by using better heat recovery process saves fuel in the utility boilers and operation of cogeneration plant remains unchanged. However, if the cogeneration plant meets the entire site's heat load, the value of saving from better heat recovery can be considerably reduced. Let us discuss condensate recovery pump. We need to recover the condensate as it is a pure water and has a lot of heat associated with it. Condensate recovery pump is operated by steam or air or gas, and it is a positive displacement pump that will lift the condensate to boiler feed water tank. Let us see the working. Steam after process heating gets converted to condensate and it is brought to flash tank. In flash tank, some condensate gets flashed and that flash steam is sent to feed water tank through deaerator. The condensate then comes to reservoir. From reservoir is goes to condensate recovery pump. Pump has a float inside. As the condensate level increases, the float will also rise. At a certain position, the float mechanism will close the condensate valve and open the motive steam valve. High pressure steam will enter from this inlet and it will exert the pressure on the condensate and the condensate will be pumped to feed water tank through deaerator. This is how motive steam is used in condensate recovery pump. Compared to conventional pumps, condensate recovery pump has certain advantages like no maintenance, no cavitation problems, no leaking of seals that happens in your ordinary pumps, no impeller wear as there is no impeller used, no electric motor problems as no motor is used, almost no moving parts. It is pre-piped, ready to install unit, rugged and easy to install. Apart, there are certain advantages like less fuel bills, less water charges as pure condensate is already available to you, less load on ETP plant because you need not to purify the water in larger amount, maximum boiler output, less blowdown losses because condensate is pure. The impurities will be less inside the feed water and therefore blowdown will also get reduced. Here are some common heat recovery systems used in industry. First, you can see an economizer which uses flue gases to heat feed water. In this, sensible heat from the gases is recovered. There is a gain in efficiency by 3 to 5% in economizer depending upon type of fuel used. Another popular device is air preheater. Again, sensible heat is recovered, and here heat of flue gases is transferred to combustion air, that is the air going for combustion. Here there is a gain in plant efficiency by 3 to 4%, again depending upon fuel. Lastly, there is a latent heat recovery which is called as condensing economizers. Normally, we cannot cool flue gases below a certain range, otherwise harmful acids can condense out and damage the waste heat recovery unit. Here, the technology is developed to recover that latent heat available in the vapors in the flue gases, and it can be used for heating water as well as air. Efficiency gain of 3 to 9% in plant efficiency can be obtained depending upon inlet air temperatures. Thank you for patient listening.